In the name of Allah, the most gracious and the most merciful. Assalamu alaikum to all. Welcome to Virtual Learning System of Pakistan International School Time. Dear students, today we are going to start the last unit of this term, unit number 12, circuits and switches. So you all open your books and come on page number 72. On page 72, we have unit number 12, circuits and switches. First of all, we are going to read this page. So come on page number 72. Electricity is a form of energy that we use every day. How many things in your home or school use electricity to work? Students, if you observe, you will see a lot of things in your home work with electricity, like television, computer, AC, bulb, tube light. Or in the same way in school, lot of things work with electricity like AC, computer, fan, tube lights. If you start counting, you will end up with a long list of electrical appliances that help make our life easier. Electricity which flows through a material is called current. When electric charges move in a wire, we say that is an electric current flow in a wire. Electric current flow like a water in a wire. Its constant flow of electrons when a wire connected to electricity or battery. Next heading is complete and incomplete circuits. The complete path along which electricity flow is called a circuit. Electricity needs a complete circuit to flow. This is called a complete or closed circuit. If there is a gap or break in a circuit, the electricity will not flow through it. This is called an incomplete or open circuit. Here you see this is an image of complete circuit. There is no gap. And that one is the image of incomplete or open circuit because there is a gap. Students, we depend on electricity in our daily lives. Electricity has made our life easier and more comfortable. Many appliances in our home and school use electricity. That are example of source of electricity, like television, radio, computer, and others. First of all, you must know that what is electricity. Electricity is a form of energy that is created from the movement of electrons of atoms. When the electrons move from one atom to the next, energy is created. The word electricity comes from the same root word as electron. So if anyone asks you what is electricity, so you must know that it is a form of energy that is created from the movement of electrons of atoms. When the electrons move from one atom to the next, energy is created. The word electricity comes from the same root word as electron. And what is electric charges? Electric charges are made up of positive charges, protons, and negative charges, electrons. When these charges flow in a circuit, a current is produced. See, positive show the proton and negative show electron. When these charges flow in a circuit, a current is produced. Here you see electricity is a flow of electrons around a circuit. See, electricity is a flow of electron around a circuit. Electricity is the flow of electrons around a circuit from a negative to positive. Electricity is a flow of electrons around a circuit from negative to positive. How does electricity flow? See, electricity flow with the help of electric circuit. Here you see. What is an electric current? The definition of electric current is an electric current is the rate of flow of electric charges in a circuit. Electric charges means proton and electron. So an electric current is the rate of flow of electric charges in a circuit. See, that is the flow of electric charges in a circuit. Again, here you see, this is the definition of electric current. These are the flow of electric charges in a circuit. See, that one show the charges, the flow of charges in a circuit. What is electricity? See, that one minus show the negative charge, proton positive charge plus, so these are the electric charges. And that one show the, these are show the electric current. Circuits. Electricity can only flow if there is a complete circuit. It travels from a power source like a battery or cell, flowing around the circuit through the components. These are called the components. Then back to the power source. See, complete circuits, the components, it means cells, battery, wires, are all connected without any gap, so the bulb lights. But here there is a gap in the circuits. The electricity cannot flow all the way round, so the bulb does not light up. See, here there is a gap, so that's why bulb does not light up. Again, here you see the definition of closed circuit, a complete path for the flow of electric current called closed circuit. See, this is the image of closed circuit. There is a complete path for the flow of electric current called complete circuit. An open circuit, in open circuit, an incomplete path for the flow of electric current. See, that one is the incomplete path because there is a gap. So that's why it is called open circuit. Here you see, before it is open circuit, when it is attached, so the electric current start flowing. See, before it is open circuit, and when it is connected, electricity start flowing, or electric current start flowing, and your oven start working. Here you see, when you put the battery on right place, after connect with the wire, then bulb is also placed in the right place. Now this is an open circuit. When the wire is attached, electric current start flowing, light, and the bulb is light up. See, first battery placed on right place, then wire, connect with the wire. After bulb placed on right place, when the wire is connected, electric current start flowing. Here you see when the wire is connected, the electric current starts flowing and the bulb light up. Switches. Sometimes we want the electric current to flow, sometimes we want it to stop flowing. For example, you want to turn on a light bulb at night, but turn it off during the day. To do this, you need a switch. A switch is a device or connection that is used to turn on or off an electrical appliances. Switches control the flow of electric current. When the switch is turned off, the current becomes incomplete, so the appliance stops working. Next is series and parallel circuits. Series and parallel circuits are the types of circuits. In the above picture, you notice that a simple circuit has three parts. A source of electricity, in this picture a battery, wire to carry the current, and an appliance like a bulb. This is an example of a simple circuit. Series circuit. In series circuits, appliances like light bulb are connected one after another. The current has only one path to flow along, so if one bulb or appliances is removed, the circuit breaks and all the other bulb or appliances stop working. The bulb have to share the energy to each bulb gets less energy and glow less brightly. Here you see switch. A switch allows us to turn the electricity in a circuit on or off. To save the energy, for example, it doesn't matter where the switch is placed. So circuits can contain other electrical devices like a fan needs a motor. So switch is used to turn on and off to save energy. Here you see, when you turn on, the bulb light up. When you turn off, the light gone. Here you see, when it's turned on, electric current start flowing. When you turn off, electric current stop flowing. Simple electrical circuits needs to be constructed correctly so that the electricity stored in the battery cell can flow around the circuits and through the bulb in order to light it up. A switch can be used to turn a circuit on or off. What do you need? What do you think you need to make a complete circuit? You need a battery, wire, switch, and light bulb. So all these things help you to make a complete circuit. Simple circuit. When the switch is closed, the lamp lights up. This is because there is a continuous path of metal for the electric current to flow around. If there were any breaks in the circuit, the current could not flow. So this is the image of simple circuit. Next is parallel circuit. In a parallel circuit, the current divides into two or more paths before going back to the battery or the source of electricity. If you remove one bulb from this circuit, the other will stay light up because each path is a complete circuit. There is more than one path for the current to flow. The bulb do not share energy with one another. So each bulb glows brighter than in a series circuit. Observe the picture of two circuits given below. See how are these circuits different from each other? In which setup will the light bulb from burn brighter? What can happen to both of the circuit if you remove one bulb from each circuit? So let's discuss. In series circuits, one pathway circuit, but in parallel circuit, two or more pathways. Current flow of electric charge same anywhere in the circuit. Current split passes through pathways and add up again. Voltage measure of strength of electrical power shared in ratio of resistance. Voltage across each path equals supply voltage. This one is a definition of series circuit and that one is the definition of parallel circuit. Let's more discuss series and parallel circuit. A series circuit is a closed circuit in which the current flows into one path. A parallel circuit is a closed circuit in which the current divides into two or more paths. Again, I repeat for you. A series circuit is a closed circuit in which the current flows into one path. A parallel circuit is a closed circuit in which the current divides into two or more paths. Here you see, this is an example of series and parallel circuits. So, image of series circuit, and that one is the image of parallel circuits. In series circuits, the components are connected end to end. See, one after another, like this. They make a simple loop for the current to flow around. If one bulb blows, it breaks the whole circuit and all the bulbs go out, like this. If one bulb blows, it breaks the whole circuit and all the bulbs go out. Series circuit. In series circuit, you just remember that if you want to label the following type of circuits, because it contains one element after another in a big loop. See, here is a big loop. That one is also the example of series circuit. Disadvantages of series circuit: if one of the bulb is taken out or damaged. See, if the one bulb is taken out or damaged, the other bulb will not light up. Why not? Open circuit. In open circuit, electricity cannot pass through the circuit. So this is the disadvantages of series circuit. If the one bulb is taken out or damaged, the other bulb will not light up. Parallel circuit. Parallel circuits are used when the items in the circuit need to be turned on and off individually. Look for more than one switch. An example of parallel circuit. Again, here you see this is the definition of parallel circuit. A parallel circuit is used to light more than one bulb at the same time. If one bulb burns out, the other bulbs will keep working. If that bulb is burned off or burns out, other bulbs keep working. They will not stop working. Advantages and disadvantages. Parallel advantages. If one light globe breaks or is switched off, the rest of light globe will remain on. In a parallel circuit, if one light globe goes out, it does not affect any other. See, if in parallel circuit, if one light globe goes out, it does not affect any other. Now, next is conductor. The next heading is conductor. In a conductor, usually matter, many of the electrons are free to move around within the conductor. Conductors are often referred to as having a sea of electrons. See, conductor is also referred as a sea of electrons. And electricity cannot flow through all materials. You know that if a material allows electricity to pass through, it is called a conductor. And the material which does not allow electricity to pass through, it is called an insulator. So keep it in mind. The material which allow electricity, it is called conductor. See here, in conductor there is a having a sea of electrons. Again, here you see conductor. Any material that allow electric current to pass through, it is called conductor. See, any metal, copper, aluminium, and steel. Insulator. In an insulator such as plastic, rubber, glass, etc., the electrons are not free to move around the entire object. They are generally restricted to moving only around the atoms they are attached to. They can move from one side of the atom to the other, but are unable to leave the atom. An insulator which does not allow electricity to pass through, it is called insulator. Then you see plastic, rubber, glass, cloth. So any material that does not allow electric current to pass through it, like the protective coating on wire, plastic, rubber, glass, or cloth, are called insulator. See here, in metal or conductor, they allow electricity to pass through. But in insulator, it does not allow electricity to pass through. I hope you understand very well. Again, here you see the difference of conductor and insulator, such as metal, taps, or salt, water, and the human body are good at conducting away any extra charges. See, touching it with your hand will discharge it. But here, insulator like plastic, rubber, pure water, and glass will not conduct away extra charge. Use rubber gloves in the lab. So that one help you to not pass electricity. Now we are going to do the exercise. So our first exercise is column A contains definition of the term and column B contains these terms. Match column A with column B. First of all, here I show you the words. Now, first of all, the complete path along which electricity flows. The complete path along which electricity flows. It is called circuit. Number one answer is circuit. The complete path along which electricity flow is called circuit. Number 2, a device or connection used to turn on or off an electrical appliances is called switch. It means number D. Number 1 answer is number C. Number 2 answer is D. Number 3, the material which allows electricity to pass through, it is called conductor. Number 3 answer is A. Number 4, the material which does not allow electricity to pass through, it is called insulator. Again we repeat, the complete path along which electricity flow, it is called circuit. A device or connection used to turn on and off an electrical appliance, it is called switch. The material which allow electricity to pass through, it is called conductor. And the material which does not allow electricity to pass through, it is called insulator. This is exercise number A, we complete on both. Exercise number B, fill in the blanks. Number 1, electricity which flow through material is called electric current. Electricity which flows through a material is called electric current. Number 2, a complete path for electricity to flow is called circuit. A complete path for electricity to flow is called circuit. Number 3, if there is a gap or break in the circuit, it is called incomplete circuit. If there is a gap or break in the circuit, it is called incomplete circuit. And if there is no gap or break in the circuit, it is called complete circuit. Number 5, the device which is used to turn on or off an electrical appliances is called a switch. The device which is used to turn on or off an electrical appliance is called a switch. Number 6, in a dash circuit, the appliances are connected in a line one after the other. In a dash circuit, the appliances are connected in a line one after the other. Series circuit. In a series circuit, the appliances are connected in a line one after the other. In a dash circuit, the current flows into different branches or paths. In a dash circuit, the current flows into different branches or paths. In a parallel circuit, the current flows into different branches or paths. Number 8, the substance which allows electricity to pass through is called a conductor. The substance which allows electricity to pass through is called a conductor. And the substance which does not allow electricity to pass through is called insulator. The substance which does not allow electricity to pass through is called insulator. This is your exercise number B. Come on, exercise number C. In exercise number C, choose the correct answer. The material which allow electricity to pass through them are called insulator, conductor, or none of above. Of course, the material which allow electricity to pass through it is called conductor. Number 2, the material which does not allow electricity to pass through them are called insulator or conductor. It is called insulator. Number 3, which of the following is an example of insulator? Rubber, copper, or silver? Rubber is example of insulator. Number 4, which of the following is an example of conductor? Rubber, copper, or wood. So copper is an example of conductor. Number 5, which of the following is an example of mains power appliances? Torch, wristwatch, or refrigerator? So refrigerator is an example of mains power appliance. Number 6, which of the following is an example of battery powered appliances? Washing machine, remote control, or air conditioner? So the right answer is remote control. In the first one, the material which allow electricity to pass through them are called conductor. The material which do not allow electricity to pass through them are called insulator. Which of the following is an example of insulator? Rubber. Which of the following is an example of conductor? Copper. Which of the following is an example of mains power appliance? Refrigerator. And which of the following is an example of battery powered appliance? Remote control. Okay. Now here, question and answers. To find the following terms, first of all, conductor. It is a definition of conductor. The material which allows electricity to pass through it is called conductor. The material which allows electricity to pass through it is called conductor. Insulator. The material which does not allow electricity to pass through it is called insulator. The material which does not allow electricity to pass through it is called insulator. Next is electric current. The electricity which flows through a material is called electric current. Circuit, the path along which the electric current moves is called a circuit. These are the definition of conductor, insulator, electric current, and circuit. Now, next question is, what is a switch used for? A switch is used to turn on or off an electric appliance. What is a switch used for? Switch is used to turn on or off an electrical appliance. Now here the next question is, compare series and parallel circuit. So first of all, see series circuit. Electricity has one path to flow. So in series circuit, electricity has one path to flow. In parallel, electricity has two or more paths to flow. In series, if one appliance is removed, others will stop working. In parallel, if one appliance is removed, other will not stop working. In series, appliances share energy, so get less energy in this circuit. In parallel, appliances do not share energy, so get more energy in this circuit. So compare series and parallel circuit. In series circuit, electricity has one path to flow. In parallel, electricity has two or more paths to flow. In series, if one appliance is removed, others will stop working. In parallel, if one appliance is removed, others will not stop working. In series, appliances share energy, so get less energy in this circuit. In parallel, appliances do not share energy, so get more energy in this circuit. So question number 6 is, what would happen if your household circuit was set in series circuit? They will not get enough current. We cannot stop any one of them. It will be wastage of electricity. And we have to pay more bills for the electricity. Question number 6. What would happen if your household circuits was set in a series circuit? Answer is they will not get enough current. We cannot stop any one of them. It will be wastage of electricity and we'll have to pay more bills for the electricity. This is your question number 6. Students, that one is your homework. Question number 4, draw and label the following circuits with a battery, wires, and 2 light bulbs in each. Question number 5, complete chart on page 77. I hope you understand this chapter very well. Okay, dear students, best of luck.